The packaging landscape is changing, and it's changing faster than ever. Sticking with conventional plastics? Well, that's becoming a riskier bet every single quarter. So in the next few minutes, we're going to cut through all the noise and give you a straight-up technical briefing on two game-changing materials that could very well define the future of your product lines. All right, here's our game plan. We'll start by looking at the core problem we're all facing, and then I'll introduce two breakthrough solutions. Then we'll get into the nitty-gritty. How do they actually perform under real-world pressure? What are the biggest hurdles to adoption? And finally, what market forces are basically making this shift inevitable? It's a clear path from a major challenge to a massive strategic opportunity. So let's just dive right into the dilemma. The very plastics that built our industry are, frankly, becoming its greatest liability. And this pressure, it's not just coming from consumers anymore. It's regulatory, it's environmental, and it is absolutely starting to hit the bottom line. This image really shows you the end game of our current model. This stuff doesn't just go away. It breaks down into tiny microplastics that are now literally everywhere, from the deepest parts of the ocean right into our own bloodstreams. And with the UN projecting that plastic pollution is going to triple by 2040, regulators are hitting the accelerator on bans, forcing our entire industry to find a viable alternative and find it fast. Now, you might remember the first attempt at a solution, bioplastics made from things like corn. They showed a lot of promise, right? But they failed a really critical test for our industry, moisture. These early versions were just way too unstable. You expose them to 85% humidity, and they could lose up to 70% of their strength. That's a total non-starter for protecting a product that goes from a factory to a humid warehouse to a store shelf. But here's the good news. That performance gap is closing. So now, let's turn to the solutions. We're talking about two new classes of materials that directly tackle those failures of the past. Okay, so on one hand, we have these things called supramolecular polymers coming out of Japan. Think of them as being engineered with bonds designed to break apart on cue, specifically in seawater, which allows for an incredibly fast and safe end of life. And on the other hand, we have advanced seaweed polymers, which use a super renewable marine resource to create these high-performance compostable films. These are the two big contenders we're going to focus on. And this brings us to the real core of this briefing, the hard data. How do these new materials actually perform under the conditions that really matter to your business? This is the fundamental challenge, the contradiction we have to solve. We need packaging that's tough enough to protect goods in human environments, but also smart enough to just disappear when its job is done. This is the paradox that those old bioplastics just couldn't solve. Now, this summary for seaweed-based films really shows the breakthrough. If you look at the row for water vapor transmission rate, you'll see it. With the right additives, things like a PLA lamination or mineral fillers, engineers have cut down water vapor transmission by over 95%. They are effectively engineering a solution to that critical moisture problem, showing us a clear path to matching the performance of conventional plastics. Let's put some hard numbers to that. Here we're looking at a direct comparison of the water vapor transmission rate, or WVTR. Our industry benchmark, LDPE plastic, sits at 0.88. It's an excellent barrier. A pure seaweed film, it's way up at 103, far too porous. But look what happens when you add just a tiny percentage of a mineral clay. That rate gets cut nearly in half. Now, are we at parity with plastic yet? No. But this shows a clear, data-driven path to closing that performance gap. Okay, now let's flip to the other side of that contradiction. What happens at the end of its life? The contrast here is just staggering. Petroleum plastic lasts for centuries. Seaweed packaging breaks down in weeks or months. But that supramolecular polymer from Japan, it is designed to completely dissolve into its raw, non-toxic parts in just 2 to 3 hours in seawater. Let me be clear, that's not just an improvement, that is a complete redesign of what a material's life cycle can be. Performance is one thing, but as an executive, you need to know about the practical hurdles. So let's talk about the real road to actually adopting these technologies. Okay, here's our baseline. The resin for conventional LDPE plastic costs about $1 per kilogram. It's cheap, it's established, and it's the number we have to beat. And here's the immediate challenge. The raw material for that seaweed packaging, sodium alginate, is currently running around $12 per kilogram. This price gap is, without a doubt, the single biggest barrier to mass adoption right now. And of course, cost isn't the only hurdle. First, there's the capital. You need over $50 million for commercial scale biorefinery. Then there's compliance. Since seaweed absorbs minerals from the ocean, these materials have to meet really strict food safety standards for things like heavy metals. And finally, integration. For this to be a seamless transition, these new materials need to be formulated as thermoplastic resins that can just drop right into your existing manufacturing equipment without a massive, expensive retooling. So you see those barriers, and you might be thinking, why are we even having this conversation? Because there are powerful market forces creating a green wave that's making these solutions not just viable, but strategic. This whole shift is being driven by a perfect storm of powerful forces. You've got global plastic bans creating hard regulatory deadlines. You have major brands setting aggressive ESG goals that actually require new materials. This turns sustainability from a nice talking point into a real competitive advantage. And the economics of seaweed itself are just compelling. It doesn't compete for land or fresh water. Plus, we're seeing smart innovations like putting seaweed farms next to offshore wind turbines that are already starting to bring production costs down. And guess what? The supply chain is starting to scale up in response. Right now, Asia totally dominates production, but the key strategic insight here is all the new investment that's pouring into Europe and North America. That's a huge signal that we're moving toward building a resilient global supply chain that's ready for industrial-scale demand. So we'll end with this one critical strategic question for your business. The cost of these new materials is on a clear downward path. At the very same time, the regulatory penalties, the consumer backlash, and the brand risk of using conventional plastics are rising steeply. The question is no longer if these two lines will cross, but when. And being prepared for that exact moment is what's going to separate the leaders from the laggards in the next decade of packaging.